Okay, so the next thing that we're gonna find is the volume of our piece of metal. So typically in math, when you find the volume of something, you do length times width times height. So because our metal is considered to be an irregular object or its size, and it's really hard to determine the actual width of this, what we do is we don't use this. We use what's called water displacement. So water displacement is when you have an initial volume, you add your object, the water level will rise, and you find the difference between whatever the volume was when the water rose to what it was originally. So you can think of it as if you've ever gotten to like a tub, or if you've ever added ice to an already like a glass of water and you saw the temperature rise. So that means that the object is taking up space somewhere in the water and inside the container, making it to where that volume is taking up some of the volume inside of the container itself. So there's three things that we're gonna have to find. The first one, I've already predetermined that volume as 50 milliliters, and I'll talk about why we're starting off with 50 milliliters. Then we're gonna find our final volume, and then afterwards, we're going to subtract those two numbers, and that will lead us to our volume of our metal. So what we're going to first find is the volume of our piece of metal that was found at the crime scene. So if we go over here. Okay, so we talked about this, or you guys wrote notes on your graduated cylinder. So this is called a 100 milliliter graduated cylinder. It goes all the way up to 100 milliliters. Put it back a little bit. Okay, and then if you took the notes on volume and on density, you would have read that this little curve line of your liquid is called the meniscus. So you always want to try to get at eye level to make sure that it's touching, or the curvature of that liquid is touching the desired volume that you want. So I originally started off with 50 milliliters. Now, before adding water, what I always suggest is take your graduated cylinder, take your object, and put it towards the bottom and see how tall your object is. You want to have enough volume to where it's going to cover your object, so you can see that definite rise in the volume. So that's where the 50 came from, and that's what we wrote on the whiteboard at the very beginning. Okay, so now I'm going to add my object. I'm just going to... Okay, so after dropping it into my graduated cylinder, I see... Let me tap that bubble out of the way. Okay, so dramatically, it only rose to about 1 milliliter. So now the volume, if I get at eye level, is at 51, and that's where my meniscus is. So if we go back to our board, okay, our final volume was 51.0, and it was directly on the 1, so that's why we only put 0 at the very end. Now, if the meniscus was, so if I draw this over here, so like if these are your two little lines and your water line or your meniscus was in between those two lines, then that's where you and your partner would guess, and I would imagine 10 little lines in between to help you, or 9 little lines to help you to determine that, okay? So really big math here. We're going to do 51 minus 50, and that's going to give us 1. So the volume of our metal is 1.0 milliliters. Okay, so that is called water displacement, and that is how you would find the volume of your objects and your metals if we were doing this lab together.